This week, what we're going to be covering, it's actually one of my favorite weeks. We're actually covering um, logic, conditional logic. So basically what that means is like a lot of programming languages, we have like if statements, that sort of thing. So that's kind of what we're going to be covering this week is how we kind of do that in a SQL way. Now, it's a little different than kind of your traditional programming, but the concept is the same. Is that we're checking for a condition, and if it evaluates to be true, then it does something. The difference is in the context of how we handle that within a database SQL kind of framework is a little different because, as you know, anytime we run a select statement, it really kicks out a table. And so that's kind of what we're going to be doing just a little bit. So just like we've done in kind of previous weeks, I'm going to kind of go through some of the exercises. We're going to talk a little bit about really most of this isn't too crazy. The only real kind of concept kind of thing is really the difference between a searched case expression and a simple case expression. So we'll kind of talk about that along the way as we do some of these exercises. So let me pull up Workbench here. And let's do. Let me try again. Sorry. There we go. All right, so let's just reuse this one here. All right, so we're going to use Sequila. And I'm going to do kind of like just a couple ones here before we jump straight into the exercises, because I kind of want to just talk generally about how it works. So, I'm going to pick on let's pick on the payment table. So I'm going to select everything from payment. Let's select everything from there. All right. And you can see here that in the payment table, we have, a couple different things like staff ID. And really what I'm looking for is like a real simple kind of solution here to kind of show how we can kind of do this. Now, case statements are these conditionals, and you'll hear me call them case statements because that's what they are. They're really kind of fall in this realm of what we call data transformation, which is where we're kind of like taking the data that we see, or like the raw data, the data that's actually there, and we're going to transform it in a way so that it's just a little bit different. And so anyways, we call these data transformations. And I'm going to show you how to do that. So you'll notice staff ID, there's really two options, right? So I'm going to select everything from here again, and I'm just going to add a new column to the end of our output. And then this is where we start our case statement. So the first one I'm going to do is going to be called a searched case. And in the book, they might start with the simple case expression, which makes sense because it's, actually, let's do both. Let's start with a simple. So let's do a simple case statement. And I'm going to rewrite this so I don't lead you down a bad path here from payment. So we're selecting everything, and then I'm going to add one. So to start off, we say case. And you'll notice as soon as I do that, it kind of opened up this little thing here because we're breaking it. But so I say case, and then I'm going to say end as, and then this is where we can kind of give it a name. And I'm going to call it, let's call it staff name. Now, this is all theoretical because we know that we could go get the staff name with a join, but we're going to kind of like cheat our way to it. So based on the staff ID, we want to do something. So I'm going to say staff ID here. So I'm going to say case staff ID. Then I'm going to say when one, then let's do Frodo. And then when two, then Gimli, right? Something like that. So let's just run that for now. Now I only have 1 and 2 here, but let's say that, there could be others and we want to compensate for everything. I'm going to say else then unknown. So just like kind of like our and not then, just else unknown. So just like in traditional programming, we kind of have like a switch here. So basically what I'm saying is case, depending on what the staff ID is, we're going to do one of two different things. If it's 1, then I return Frodo. If it's 2, then Gimli. Otherwise, we're going to put unknown. So let's go ahead and run this, see what we get. And now you'll notice out here at the end, basically it just does exactly what we would do. If the staff ID is 1, we're going to put Frodo. If it's 2, we're going to put Gimli. Now, there isn't any unknowns, I don't believe. So we don't have any unknowns, but I always like to put an else statement with something along these lines, just so we know we're not missing something. So that's the simple one, right? And that one works great when it's just simple values. However, sometimes when you need to do more things, you may have to do what's called a search expression. And the difference is, I'm going to grab this. The difference is really subtle, but it's just a lot more powerful, the search. So we can say case, and what I'm going to do is I'm going to say when staff ID is equal to 1, then Frodo. When staff ID is equal to 2, then Gimli. Oh, and I spelled his name wrong earlier. Else unknown. Let's fix this. There. So the first one was a simple case expression, and this one is a searched case statement. So now you can see the difference is really subtle. Like I said, with the simple, you put the variable that you're switching against first, and then you just say when value, then value. With a search case statement, each line item, you build your own logic chain. So in this case, we say when staff ID equals 1, then Frodo. When staff ID equals 2, then Gimli, else unknown. So let's run this, just make sure it works. Same exact output, just one's using one versus the other. Now, why do we want to use the search case statement over some others? Well, let's say we wanted to add like a certain kind of rule, right? So we're going to say, hey, like if it's 1 or 2, then it's Frodo and Gimli as the staff name. But let's say that we say any movie that's over $4.99 has to be approved by a manager, right? So let's say we're just like giving credit to whoever did most of the work. Let's say that, hey, if the movie was over $4.99, then a manager had to approve it. And so they should get the commission credit. So we're going to say when amount is greater than, or let's just say greater than $4.99, then manager. Right. So you can see that all of a sudden we added like a whole different element to this. And so now let's run it. And now you'll see there's a couple managers in there. And so that's where the search case statement comes in, is because you can build each little line item, you can do a lot of different things. Like, for example, let's say that Gimli is the manager, right? So I'm going to say when amount is equal to $4.99 and staff ID does not equal 2, right? Because 2 is Gimli and he is the manager, then we'll do that. So, kind of, let's say that the manager can change, but Gimli is a manager. It's kind of a weird scenario. But the point is that you can combine logic. So we can say, you could build this forever, some crazy logic, and it would work. And that's the power of the searched case statement. And so 99% of the time you're going to be using a search case statement because you can do a bunch of different stuff. Now, the one important thing to remember is that case statements are order of operations, right? So let's say that I have 2 conflicting items. So like I'm going to take this out. We'll just leave it at the $4.99. So let's say I were to move this rule to the end. So I'm just going to cut this. We're going to put it down at the bottom. Now, every row already has a staff ID, so it's largely going to fit in these 2 buckets. So that's where it kind of gets interesting with SQL, is because it's order of operations, meaning it evaluates rules in the order that they're listed. And as soon as one evaluates to true, it quits. It's done. So it's kind of exhaustive. So as soon as it meets one rule, it's done. So you'll notice, even though we have movies over $4.99, it will never hit manager because these two always satisfy the rules. So you need to think through, like, okay, order of operations as you do this, which one do I want to hit first and be exhaustive with, because it does matter. Does that make sense? The ordering?
Yes.
Perfect. All right. Let's jump over to the exercises. All right. So question 1 has to do just with that. Rewrite the following query, which uses a simple case expression so that the same results are achieved using a searched case expression. So just like we did, you'll notice that it's got the switch up here. So this is a simple, and we want to turn it into a searched. So let's just grab this. And we'll come down here a little bit. This is number 1. Paste this, and we'll just get rid of all this garbage here. This is where it's nice to have that multi-line editing. All right. I always like to just make mine nice and clean like that. There we go. So let's run this. And there you go. You can see it outputs exactly like it shows. And we just want to change this to a searched case expression. So basically, we're going to take out this here, and we're just going to say when name equals English. And we're just going to do this. And basically, this is where the search simple is nice, because you can kind of do it in one go, but not too bad. So anyways, exact same. The only difference is we have to evaluate each line on its own, and that's the searched. All right. And if we look at this, it says also try to use as few when clauses as possible. So we can kind of switch this around. So let's just call this phase 1 for the sake of seeing how this works. So to use it as few as possible, you can see that we're lumping more into Latin than we are these others. Or we can kind of do a couple other things. So what we can do is we can kind of concatenate these like this using or clauses. And I guess that's it. So as long as it's one of those, then it's Latin. And if it's one of those, then it's one of those. Oh, and what did I mess up? Oh, I had one too many there. There we go. There we go. So now we can see we get the exact same result set. Basically, we just kind of swapped it around. Now, there is one way to make this even easier. We can say when name is in, and we can basically just make these comma separated. Same thing here. And that is probably the cleanest solution right there. So you can see that we basically get the same effect, but because it's searched, now we have the ability to do this kind of stuff. All right, there's number 1. Number 2, it says rewrite the following query so that the result set contains a single row with 5 columns, 1 for each rating. So this is actually one of my favorite ones, This is really, I think, where the concept of data transformation really comes into effect, and to really powerful effect for that matter. So this is actually where I get really excited because I actually kind of live my life in a world of analytics. And so this is where, to me, the rubber meets the road, so to speak. And so I really like this. Let's get it like this so we can see what's going on. All right. So basically what we're doing right off the rip here is we're getting the count of all of our films based on their rating. So, hey, out of all of our stores, how many movies do we have within each rating? Right. And basically what we want to see instead is instead of seeing it like this, where we have rows, we want to pivot that into columns. So we have a column for each movie rating and then the count underneath. So kind of a little different. So how do we do that? Well, it's actually not near as bad as you think. So we start off with our same data, right? The first thing always with SQL that I like to think about is, first I need to get whatever I'm doing. And, in typical manner, that's rows. It's in table format. And then from there, we can transform it. But first we need to just aggregate the data. So that's what we're doing here. So we're getting the counts in by rating. So what we're going to do now, though, instead is we're going to adjust this just a little bit because we want each column, meaning, in here, to be a little different. So we're going to take off this this count and this rating. So we don't care about those anymore. And what we're going to do is we're going to have each one of these be a thing. So like, let's say I'm just going to like hard code this for now, but I'm going to say 194 as, and I'm going to get as, well, I guess let's just do it for real. So we know we want to count. And I'm going to say, let's get rid of our group by too, actually. So we know we want to count. So let's just start here. So if I want to count from film, there we go. We have 1,000. Now what I'm going to do is I'm going to change this just a little bit using our newfound case statements. And I'm going to say case when, what's our first rating? G. Case when rating equals G, then film ID. End. So you can see I just built my case statement in here, and you'll see that I only have one. And it's just, hey, when the rating is equal to G, return the film ID. But then you can see I'm counting, and I'm going to do a count distinct. You can see I'm doing a count distinct of whatever this returns. So in the end, it's going to count film ID, but only for when rating equals G. So I'm going to say as G. All right, so 178. If we take a look, it's right where we want to be. So that's one, right? Which is pretty nifty. And so then what we can do is we can just mimic this. And this is where it's really fun. These case statements, you can really do a lot of cool things with them to kind of transform these columns. Whoops. So G, where do we go? We go G, PG, PG-13, R, NC-17. G, PG, PG-13, R, NC-17. And we're going to call this one PG, PG-13, R, and 17. Film. There you go. So now you can see that, each one of these is now its own column. Anyways, pretty neat, pretty nifty. And I guess just to kind of take this one step further. So let's call this number 3. And, why is this important? Well, why would you want to put these onto rows? And well, let me show you. So if we wanted to do this, what I'm going to do is I'm going to take, what do we have in film even? In film, we have release year, right? So let's take a look at our release year. Let's say I want to say, hey, what are the, let's say we're doing an analysis. So we want to say, hey, how have the ratings of movies changed over time, right? So this would be a perfect example of how we could answer that question. So the only difference now is we're going to say group by release year. Because once we aggregate, we need to do that. So let's run this. Oh, and naturally they're all in 2016. That's boring. Let's try one more. Let's try left. And we are going to get the name of the film. Title. We're going to get the title. Toll. There we go. So basically we're going to do the same thing, but instead of grouping it by release year, we're going to do it by the title. That way maybe we can see just like a little bit more fun results. So here we can see, which letter of the alphabet, the title of the movie has, the most ratings by the letter. And if we wanted to, we could even add one more column here and just say, hey, you know what? For our last little line, we just want to count the distinct film ID as total. Right. So now we can run this. And boom. There we go. So now we can see, all these should sum up to the total. And we could even go one step further. Again, this is where my analysis brain comes in. So we have our total and we also have our amounts for each one. So let's just do some division. And now we can see percentage wise what each one is. So we can see that for the letter A, 22% are G rated, 15% PG, 20% PG-13, 20% rated R, and 24% NC-17 for those that start with the letter A. Not a particularly valid experiment, but nonetheless, we can do it. But anyways, you can kind of see how you can get to some really neat reports just by using raw SQL, which is really neat. So no Excel needed. You can actually just generate this right out of SQL, which is really cool. Okay. Sorry, that was question 2. I really jumped the gun. Question 2. All right, question 3. All right, so this one wants you to look at, basically these active counts. And this is really similar to actually what we just did. In fact, really similar. So what I'm going to do is I'm actually going to leave this one to you guys because I don't want to do it all. But, inside of the customer table, select everything from customer. You'll notice that there's this active flag. So that is your active customers. So you can do exactly what we did here. You'll just count, I guess here, you'll just count them. The only difference is we're going to add that group by, and you'll group that by the letter of their name. So pretty nice and easy. We actually did it not intentionally. We did like almost the exact same thing here. So I'll leave that one to you guys. Let's see. Got it. Okay. So now the one key to this one is it says limit the results only to those first letters that occur in the last name column of the customer table. So that's question number 3. And in question number 4, it wants you to include all letters of the alphabet. So you'll notice letter Z is here with 0 and 0. Meanwhile, up here, there are no customers with letter Z. So that's a difference from here. So let's do the same thing. So you'll notice in this one, same thing. If I were to run this, before I do this, let's just make sure A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X. You'll notice that there's not an X. We got lucky. There's no X movies. So anyways, in this case, we would want to show X here, but just have it be 0 because there are no films that start with that letter. So what we're going to do first, what we need to do is and it says this in the instructions, it says you will need to fabricate a table composed of the 26 letters of the alphabet. And it says you can use an outer join to resolve this problem. So anyways, basically there's a lot of different ways to solve this problem. You could union everything together, all that sort of thing. So what I like to do, and I'm completely okay with you guys doing this, is you can actually just create an alphabet table on the fly. So what we'll do is we know that we already have the bulk of them. So what I'm going to do is I'm going to say select distinct, the left, title, and it could be any table for that matter. I just know that we're only missing Z from this, so that's why I'm going to do that. So from film, I'm going to select the distinct first letter of the word. So you can see here, same thing. We're just missing that X. So what I'm going to do is I'm going to cheat. I'm just going to say, union select X. And when I run this, X should just be at the bottom, just like that. And I'm going to say create table. Well, first let me drop it because I already have one. Drop table alphabet. If you ever need to drop a table, you can just drop it. That gets rid of it. And then I'm going to say create table alphabet as. So you just say create table, the name of the table as, and then you can run your column here. And I'm going to say order by 1, put it in alphabetical order. Boom. There we go. So that just created the table. So now what I can do is I can just say select everything from alphabet. And there we go. So now you'll notice that I have all of my letters here. All right, so now that I have my letters of the alphabet, what I want to do now is I want to take our exact same exercise, and I'm going to do this one instead of the customer names. And I want to have them all. So instead of having this up here, what I'm going to do is I'm going to do a join. So what I'm going to do is I'm going to say left from film instead of starting from film. And we could cheat actually. Let's do this. We'll do it both ways. Get our join practice in. Since I already have film there, I'm going to write join to alphabet. And what that does is it makes it so we get all the alphabet and anything that matches to it. And what we're going to match on is we're going to match on A dot letter is equal to F dot. And it's just this. We'll put F dot title. And then up here, I'm going to say A dot letter. And then we can change our group by to be A dot letter. So now let's run this. Let's see if our X is there. And sure enough, there it is. There's our X. Now you'll notice that those are null. And, that's okay. It's really because we're doing this, the division. I'm going to take this out just so you can see what it should look like with yours. Because if the count is null, the total thing is always going to equate to null. So if we run this, the count will now be 0 for X across the board. Does that make sense? All right. And what I'm going to do now is I'm just, so we don't get confused with this right join, I'm just going to swap these. Now, if I keep this a right join, what we'll do is we'll have everything but X again, right? Because it's a right, meaning it's starting with film. And we can just change this because we just changed the order of operations. We just swap the direction, left, right, doesn't matter. Just depends on which table comes first. In this case, we want to start with alphabet, so we go left. And there it is. There we go. We got a 2 for there. Joins and case statements. All right. It says write a query that returns the alphabetized first letter of the customer's last name and the count of the active and inactive customers only for those letters where the count of active customers is greater than 30. So in this case, it says, hey, we only want to see the letters of the alphabet who have an active count over 30. So again, I'm not going to do this one for you, but let's use our same example here. So it's the exact same thing. We just happen to have more columns. So what I'm going to do is, again, we only want to see it. So let's say we only want to see it where the G-rated movies are greater than 10 or greater. So we already have the group by. And if you remember right, there's a special clause that we use for aggregation, and that's the having clause. It's basically the where clause of aggregation, which is what we're doing here. Anytime we do a count, sum, or anything like that, we're doing aggregation. So in this case, I'm going to say having, and we're going to just do almost the same thing, right? So rated G. So I'm actually going to cheat and just take, no need to reinvent the wheel. Our count that calculates G, and we're going to say is greater than or equal to 10. So we only want to see the letters that are greater than or equal to 10. And boom, there we go. You'll notice that now we only see the G's that are 10 or greater. And that's the having clause. Making sense so far? Everyone good?
Yes.
Okay. Do you have any questions? And don't feel bad. I mean, feel free to ask. This stuff is more on the complex side that we're doing here.
Yeah, it's the logic and the math that throw me each time, so it's all good. What you're
Okay.
doing makes sense, but I don't. Yeah.
Okay, I'm gonna do just a couple. I kind of want to do a couple anyway, so don't feel like you're making me do this because I was gonna do it anyways. Because in this we always do counts. In the exercises they only do counts. So I was gonna show you just a couple quick sums, just some other math essentially. So maybe just seeing like a couple other examples will hopefully help reinforce, because I know like these ones start to get a little bit, we're doing a lot here. So what I'm going to do is I'm going to go into this payment table again. So let's select everything from payment P. All right, so we see our stuff here. We see all of our rentals, our amounts, all that kind of fun stuff. Well, first let me make sure we're to the end here. Yep. Okay. So we see all of our amounts and that sort of thing. So let's say we wanted to kind of see like, hey, what is our revenue by the film, right? The film rating. So really similar. So what I'm going to do is I'm going to just start with our join. So I'm going to say left join, and you can see we have our rental ID. So I'm going to go to there, rental R on P dot rental ID is equal to R dot rental ID. And this first part, I'm going to completely steer clear of the case statement. We're just going to kind of gather our data first. So we have that. And then I'm going to get our, let's see, what do we have in rental? Side of a rental, we have an inventory ID. So let's go to inventory I on R dot inventory ID goes I dot inventory ID. And then I'm going to left join that. And now we're finally to the film ID. So then we're going to go to I dot film ID, F dot film ID. All right. And basically what this is going to be, it's going to be a long scrolly table that has our payment. So like, for example, this first one, we can see that they paid $299 for that rental. And we can scroll all the way over here and actually see what film that was. So it was Patient Sister. Anyways, so then we can kind of see like exactly what that was. The rental ID 76. Let's see, did I do this right? Inventory, rental, film ID. Yes, okay. Got it. So the rental duration. So here we can see like, basically how long they rented the movie and why that, anyways, we can see all of it. And we can see the rating more importantly. So this is kind of like our base data. And that's kind of like where I always like to kind of start is like, okay, once I kind of have all my data wrangled, everything that I need, then I can transform it. And so this is kind of where I like to start. There's no aggregation at this point, nothing crazy. And then what I want to do is then I kind of first do kind of like our basic kind of pivot where I say, okay, yeah, now I want to see, the rating. So film.rating. And I want to see the sum of total revenue by that. So let's add in the total revenue, which is our P dot amount, how much they paid. And we're going to call that revenue. And we can run this. And let's see, where did we go wrong here? Oh, and naturally, yeah, we forgot the group by. So now that we have our sum, because we're adding in rating, and again, let's just do this. I'm going to take that out. We can see how much total we made, but as soon as I add in the rating, then we need to group it. Group by rating. We can run this. And boom. There we go. So now we can kind of see how much money we made by each rating. Now, this is really like a one-dimensional kind of look. It's like a total snapshot. Now, let's say we wanted to see this also with the year of, let's say we wanted to say, hey, what year was it, right? We could do that, So let's do, so we have the rating, but we want to see it first by the year. And what we're doing is we're adding dimensions. So the revenue in this case is the metric. What are we aggregating? And then what we're doing is we're adding what I like to call, or what industry standard calls dimensions, which is how are we slicing up the data. So what I'm going to do is I'm going to say the P dot, I think it's payment date. Let's look at payment date. Yep, there it is. So what I'm going to do is I'm just going to get the year of payment date. We're just going to call that year. And it probably doesn't like my year column name. Oh, it's because we need to add it to the group by. So now we need to add, again, anytime you're doing aggregation, it's whatever your dimensions are, That's what you need to have included in the group by. So there we go. So now we can see this. Now, in this case, again, I always kind of like to go stepwise and kind of see it. So now we see it in tabular or row format here, where we can see like, oh, 2005, NC17, here's our revenue, so on and so forth. But as we all know, with reporting, it's all about visualizing it and, hey, I want to compare how PG did between the 2 years easier. I mean, I can look it up, but it's kind of hard to see. And so what we're going to do is we'll transform this so that it works. And basically how we do that is we're just going to pivot the ratings into their own kind of columns, just like we did before. So I'm going to take rating out of here. And then we're going to do this. Now I'm going to keep this one. I'm going to call it total revenue. And I'm going to add in, and this is where our case statements come in. So I'm going to say case one F dot rating is equal to G, then P dot amount. And I guess like a good way to think about it is whatever we, let's do this, G revenue. I guess a good way to think about it, if I were to take this back here again, paste this here, and just say, hey, let's select the F dot rating, and let's select, let's just do a case statement. I'm going to say case when F dot rating equal to G, then P dot amount, and as revenue. Let's just run this without the aggregation so we can kind of see what's going on. We don't need to group by, so we can take that out. That's why it's complaining. Boom, there we go. So here's what it's kind of doing under the hood. You can see that in the results that anything that isn't rated G, it doesn't return anything because we don't have a statement for it. If we were to put else, P dot amount, then it would return it for everything, but we didn't. So it only returns P dot amount for when this is true. So for every G movie, it's just returning what the actual amount is. So it's kind of like a little hack, a way to kind of trick the computer into saying, hey, filter this within its column, create a new column that's filtered, so to speak, which is kind of nifty. So that's kind of what we're doing here. So we take this and, let's just do it for G and PG. Let's just say we want to just compare the two. So now when we run this, you can see that we've pivoted this and helps make it just a little bit easier. So you can see that in the year 2005, we, and my guess is that 2006 isn't really over, and so we can kind of see how that's going. So again, this isn't necessarily part of the course, but me being an analytical person says, oh, let's normalize. If we're tracking to say, hey, we want to rent a certain amount of this, over the course of time, and I'm going to keep this in here. We're going to just keep the raw amounts because it's always handy to see the actual amounts. And what I'm going to do is I'm just going to divide it just like we did before. And then that way we normalize where this year is still in progress. We take the total amount per year and we're going to call it percent G. And then we'll do the same thing here. And we'll call it, let's call it G percent, PG percent. And now we can see like what the percentage of revenue is across the two. So now we have like a more equitable metric. So we can see that in 2005, 17% of our revenue was rated G. So far in 2006, 17%, 2006, 20% is now. So we're actually doing more rated G movies, and you could say like, oh, who do we market to? Are we marketing to kids, families, or adults? And so that's where all this comes into play. So you can actually kind of build this kind of reporting. But anyways, hopefully that helps. Hopefully it didn't make it more confusing. Like I said, if you ever really want to kind of like, just like we did up here, if you kind of want to see what's going on under the hood, just back the aggregation out of it and you can run it very plain and kind of see like what's going on. Like, so, we could essentially do this. The only difference is we then aggregate after the fact. So if we're going to run this, we're just going to say PG revenue from payment. And you can see that, hey, we're not going to get any that way. Let's try it again. There we go. So you can see that by just adding this case statement, we're building our columns, but we're only limiting in what we want. And so that way, when we sum it, it's only the sum of those things, if that makes sense. So it's kind of a hack, but it's a cool one. It's a really cool data transformation trick that I use actually just about every day. So it is a really cool, it's not some odd thing. It's not some weird thing we're doing for an assignment to make life hard. This is actually really cool stuff that I use a lot that I wish I would have known earlier because it is super powerful. So anyways, that's all I got. Does anyone have any questions before we jump?
No, the real life example, that was much better than the count. So no, that made a lot more sense. Thank you.
Yep, no problem. And I guess like a good spinoff, just that once we have this aggregated, we can do a lot of things. So because we have all of our data here, to that end, like you said with the counts, a lot of times what we end up doing in real life is it's not just like a revenue. Maybe it's how many films. So what I'm going to do is I'm going to take out just the PG stuff. Like let's say we just want to look at our rated G films. I could add in a metric here, just like we did with the sum. But instead I'm going to count distinct the films. And in the same way, what we can do is we can build in multiple metrics. So I'm going to call this G rentals. So then you can kind of see exactly kind of like what's going on. So, and this is where it gets really interesting because now we can build in metrics that are things like, hey, what was our total revenue for G-rated movies? And we can divide that by the number of G-rated rentals we had. And what would that give us? Well, that would give us our average rev per rental. So you can kind of see how you can really start to like kind of bake in this a lot of these cool metrics. So you can kind of like really start to like dissect the data in meaningful ways. In a lot of different metrics. It doesn't all have to just be sums. It can be percentages. It can be counts. It can be sums. All sorts of stuff. So, anyways, great. Well, if there's no more questions, I'll jump. But if you get any along the way, like I said, this is getting more into like kind of like the end game kind of stuff. Here we are in week 10. There's only a few weeks left of the course, so we're kind of getting more into that advanced stuff, which is both fun but also comes with its challenges. So if you have any questions, feel free to reach out. Happy to answer them. But otherwise, good luck this week.
Thank you so much.
Yep. Thank you.